All right, hello everybody. Today we're going to talk about variance and standard deviation using raw data. So to start with this particular topic, we have to look at the basics first. Basically, when you are dealing with a variance or standard deviation, first you have to know how to find the mean. Okay, later I'm going to explain why the importance of the mean in terms of looking at the variance and standard deviation. Yeah, it's so difficult to talk about variance and standard deviation without talking about the mean or the average. So assuming that we have these scores here or numbers 250 to 80, we call this as scores in statistics or our values. And also we can call this as our observations. So 250 to 80, 330, 350 until 210. Find the average of this data. So as mentioned in our class, to find the average, we have to add all the values from 250 until 210. We divide by the total number. So this is the number of scores. So we have 8, 2, 4, 6, 8. So our average is 2340 divided by 8, 292.5. Okay? So what is the meaning of this value? This value actually is the representative of our data. It tells us that our numbers are around 292.5. It means that there are numbers close to this value, below this value, and above this value. Okay? So now in terms of rounding the answer in decimal places, it is important to note that from 5 until 9, we have to add 1. Okay, if it is below 5, like 0, 1, 2, 3, 4, we have to retain the digit. Okay, we have to retain. So for example, we have 2.53, 5 to 7623, and we want to round this up to 5 decimal places. This will become 2.53528. This is the first, second, the third, the fourth, and the fifth. So this is our target, 7. Now we have to look at the digit after 7 because we are rounding up to 5 decimal places. As I said, if the next number is from 5 until 9, we have to add 1. So here the next number is 6. So 7 here will become 8. So instead of 53527, it becomes 53528. Okay, so for the next number here, assuming we have 2.57878356, around to 5 decimal places, it will become 2.57878. This is the first, second, third, fourth, and fifth. Because next to that is 3, 0, 1, 2, 3, 4. We have to retain the digit. So 8 here will remain 8. It will not become 9. Okay? So I hope this is clear how to round off our number into certain decimal places. Okay, let's now talk about the variance and the standard deviation. Okay, for example, we have here the marks of students out of 100, assuming that the scores are 65, 55, 62, 60, and 58. As I said, we have to start with the mean or the average when we talk about the variance and standard deviation. Because basically, when we say variance or standard deviation, we are looking at the distance of the scores from the mean. Okay, whether the scores are far from the mean or close to the mean. Okay, so the second, for example, here we have 97, 93, 37, 35, and 38. We are talking about, again, marks of students, second group of students. So the first one is our first group, and here we have our second group. Okay, so if you're going to look at the numbers, we have 97, 93, 37, 35, 38. 37, 35, 38 are away from 97 and 93. So this affects our answer. The first set of data, 65, 55, 62, 60, and 58, they're close to each other. So this will have a smaller variance or standard deviation. So let's see. First, we're going to start with the manual method, how to find the variance and standard deviation using the manual method. And later, I'm going to show you the method using the formula. Right? So for you to understand, let's start with the manual. So the average here is 60. That is 65 plus 55 plus 62 plus 60 plus 58 divided by 5. The answer is 60. Okay? And here, the average is also 60. If you're going to add 97, 93, 37, 35, and 38. Okay? So the average of the first group of students is the first, and the second group of students, their averages are equal, 60 and 60. But the numbers are different. Here we have 65 to 58, here we have 97 to 38. So sometimes the averages are the same or the means are equal, but the numbers are not the same. Of course, it can happen because we are adding all the values all over the number of values or the number of scores. So it can happen. But it doesn't mean that if the means or the averages are equal, they will have also equal variance and standard deviation. No. Please take note that the variance and standard deviation are not equal if the means are equal or the averages are equal. Okay, so let's look at the manual method first. Using the manual method, we're going to look at the difference between the scores and the average. Okay, so the first difference is -5. How to get -5? That is 60 minus the score. Okay, the mean minus x. X is the score. Okay, that's how to do it. Second one is 60 minus 55, that is 5. And then 60 minus 62, third number, that is -2. And then 60 minus 60 is 0. And then 60 and 58, that is 2. Okay, so basically we are looking at the differences, okay? The differences of the scores from the mean. So 60 minus 65 is -5. Okay, what's happening here? Okay, so these are the deviations or the differences, okay, between the scores and the mean. Now, to get the variance, we have to square all the numbers, all these differences, and add all to make it all positive. Okay? So divide by the number of items, number of scores. So divide by 5, we're going to get 58 divided by 5 equals 11.6. 11.6 is the variance. Okay. So our variance is our tool to get the standard deviation. So before we get the standard deviation, let us look at the second uh, group, the second example. We have basically 97, so 60 minus 97 is negative 37. 60 minus 93 is negative 33. 60 minus 23, minus 37 is 23. 60 minus 35 is 25, and 60 minus 38 is 22. Okay, so again, we are subtracting like what we did here, the mean minus every score. This is the x. And of course, we're going to add all the squares of every difference and then divide by the number, divide by 5. So 4096 over 5, that is 819.2. Now, as you can see, the variance of the first data set is smaller than the variance of the second data set. Why? Because as you can see, the deviations, the differences are bigger. Here we have only 5 and 2 as the differences from the mean. Here, the differences from the mean are higher. So that makes our variance very high, 819.2. So it tells us that most of the scores are away from the average or the mean. Okay, so a low variance means that most of the data values are very close to the average, which gives good result like here. A high variance means that the numbers are spread out, which does not give a good result, as you can see here, very high. Okay, so this tells us that the numbers are mostly away from the mean, away from the average. Okay, so this is the manual method of finding the variance. To find the standard deviation, the formula is very simple, the square root of the variance. So the square root of 11.6 is equal to 3.4 something, okay? And for the second one, we have the square root of 819.2, that is 28.1. So it's very easy to calculate the standard deviation, that is the square root of the variance. So the standard deviation is the average distance of the scores from the mean. So here, the average distance of the scores from the mean is 3.4. Yes, that's fine because we have 5, 5, and 2. So the average distance is 3.4. Here we have 37, 37, 33, 23, 25, 22. So 37, 33, 23, 25, 22. The average distance is 28.1. It's like the average of these values, 37, 33, 23, 25, and 22. Okay, so standard deviation is somehow the average distance of the scores from the mean. The smaller the standard deviation, of course, the better. It means that most of the scores are close to the mean. So let's now use the formula. This method here is manual method. In your exam, I don't suggest that you use the manual method. I'm suggesting that you use the formula, this formula. Okay, so the formula is very simple. This summation or sigma x squared over the number minus the mean square, or the mean is x raised to the power of bars, or x bar, something like that. Okay, x bar is the mean or the average. The average or the mean is x bar. In population, we use this symbol mu as our mean or average. But anyway, the calculation will not change. We talk about population mean. This is population mean. And here we have the sample mean. Sample is usually used because we cannot, include everything usually when we analyze our data. For example, if you want to know how many people eat fish in China, for example, if you're going to include the whole population of China, that is close to 1.4 billion, 1.2, 1.3 billion. So it's not feasible to do that. We cannot ask all of these people when we're going to finish. It will take hundreds of years. Okay, so usually we take a sample, maybe we take 50 people in one city and 50 again in a different city. And based on that, we conclude. Okay, so usually we use a sample. This is sample mean. We don't include all the people involved. For example, if you want to know the performance of mathematics at Majan, it's difficult to include all the students, more than 2,000 students. Maybe we can look at, like 150 students in foundation and maybe 200 students in the undergraduate program, IT, business, or English, and then conclude. Okay, so in statistics, usually we use a sample. Okay, so the formula is very simple. We have sigma x squared. Sigma is the total. We have to square the scores, divide by n minus the mean. Standard deviation, as I said, is the square root of the variance. So what is inside is the variance. Right, so for the first one, a while ago, we have 65, 55, 62, 60, and 58. A while ago, we solved this using the manual method. So now what we're going to do is to use the formula. The formula is given here on the right. So as I said, the first is to square our x. X here is every score or the mark, because we talk about marks of students here. So 65, 55. Okay, this is the best method, vertical. And then we square. Okay, we square the score, 65. So 65 raised to the power of 2. Then 55 square until 58 squared. So 65 squared, that is 4225 in your calculator. Just press this, or 65 times 65. Okay, so we have x squared, and here the answer when you square the value. So here the total, you have to add all 18058. That is the total of x squared. Okay, so this is the total. We divide by n. Our n is 5 minus 60. 60 is the mean. Okay, we solved this a while ago. 65 plus 55 plus 60 plus 58 all over 5. Answer is 60 raised to the power of 2. Answer is 11.6. Right? So this is what I was talking about a while ago. We solved this already using the manual method. The answer is 11.6 in terms of the variance. Standard deviation is the square root of 11.6. So approximately that is 3.4. Right? So this is what we're going to use in the test. Use the formula to calculate or to solve for the variance and the standard deviation. Let's now have more examples for you to understand better. Here you're going to calculate the variance and standard deviation. We have two decimal places. These are the numbers 32 to 28. So the formula is given sigma x squared over n minus the mean square. So basically you have to create two columns. The first column is the x followed by x squared. X, of course, this is the score. The list of scores 32, and then we have 21, 15, 17, 15, 28. Okay, so square, that is 32 raised to the power of 2 equals 1024, or 32 times 32. Okay, and then 21 squared, 441, 15 squared, 17 squared, then 15 squared, 28 squared. Then you have to get the total of x and the total of the x squared. Add all of this, total, and add all of this. Okay, so now we can plug in the values here. You have to 1, 2, 3, 4, 5, 6. So the mean is the total of x over n. So immediately you can put it here. So we have our x squared. The total is 2988. Our n is 6. We have 1, 2, 3, 4, 5, 6. And the mean is 128 over 6. That is, of course, 21.333. You can put this, but to get the exact answer, please put this inside the open and close parentheses. Okay? So, like this. Because sometimes, it is non-terminating. That means it will not stop, so we cannot write all. So, put here the fraction 128 over 6. So, the answer is 42.888. Two decimal places, 42.89. Because 8 is the next second, so plus 1. Okay, so it's very simple to find the variance. We just have to get the sum of x squared over the total number of items minus the mean square. So the standard deviation is the square root of the answer above. The square root of the variance, 42.89, equals 6.55 something. Okay, so I hope this is clear. Let's proceed to the next. We have 12, 20, 18, 11, 15, and 10. This one. Okay, so square 12 times 12, 12 square equals 144. 20 squared is 400, 18 squared, 324, 11 squared equals 121, 15 squared, and 10 squared. So very simple. And then add all. So we have 1314, total of x squared and total of x is 86. The total of x squared, 1314 divides 6. So 1, 2, 3, 4, 5, 6. And the mean is 86 over 6. Okay, so as I said, you use the fraction. 1314 over 6 minus 86 over 6 squared, 13.56. But since we have 3 decimal places. Okay, so 1, 2, 3. The next is 5. This will be plus 1. So 5, 5, 6. The standard deviation is the square root of the variance. Square root of 13.556 is 3.682. So it's small because the numbers are close to each other and close to the mean. Our mean is 14.33. Okay, so this is an additional example. We have 23 until 12. So we have to follow the same method where we square all the numbers, 23 squared, 22 squared, and so on. So these are the squares we added and the sum of x. Then we get the sigma x squared 1772 over 7 because 1, 2, 3, 4, 5, 6, 7. Okay, so we substitute these values. Okay, here over 7. Be careful because we have total number of scores 7. This is the variance and the standard deviation. The standard deviation will be 4.88, 2 decimal places. Okay, so thank you so much for watching. I hope that you learned something. This is how to calculate the variance and of course the standard deviation. Thank you so much.